And the beer du jour is Temple Star 2 from Low Life Brewing in Winnipeg. They describe it as a New World Brett Saison. Brett being a type of hops and Saison being this style of beer. So they say down here that it's been aged on cherries, and that goes with their tasting notes, which indicate that it's earthy and cherry. Not my usual style, but yeah, you got to go out on a limb now and again. Yeah, there is a strong fruit flavor in there. It's going to be an interesting evening. So, I am tonight going to do the second half of that radio kit set that I got a while ago. I did the receiver. No, I didn't. I did the transmitter a few weeks ago, and I'll put a link to that up there. Here is the receiver kit, which is a much simpler kit and a little bit trickier for new players. These may look like resistors, but I believe they are actually inductors. And then what else is in here? A little pin of some sort. We got a couple of push buttons, earphone output, third push button, fourth push button, fifth push button, small handful of capacitors, one actual resistor. Oh, that is a crystal. That is the oscillator that the time base of the receiver is based on. And then we have this itty bitty chip, which is an RDA 5807, which is of course an FM receiver chip all in one. Very few support components to make it work. As I said, just a few inductors and capacitors and some push buttons to select modes and the oscillator. So let's get busy with this simple little kit. Actually, before we do that, let's look at the schematic, which again is very simple because 90% of this is just in this one chip. We have the crystal oscillator, 32.768 kilohertz, a very common, very standard frequency for watch crystals. We have a capacitor, 3 volts worth of batteries, handful of push buttons scattered around. We have channel up and down push buttons, volume up and down push buttons, power button, and then it's 3 inductors. There are literally no resistors. Okay. And a couple of DC block capacitors going out to the stereo headphone output. Let's see if we can look up that chip, actually. Maybe that'll tell us more. Yeah, to nobody's surprise, it is a single chip FM receiver module with everything going on inside it. We have a low noise amplifier. We have a couple of RF mixers. We have a couple more amplifiers, analog to digital converter, and audio digital signal processing core. That's interesting. So it digitizes it and then analogizes it again from these two digital analog converters. Okay. And then, of course, the crystal input through a synthesizer, through a voltage-controlled oscillator, into the mixers, mixes with the incoming RF. Boom, done. Oh, it has an I2C control interface. So I could control it with... Oh, okay. Yeah, right. That microcontroller is external. Okay. And just for funsies, I am going to use this 3D printed circuit board holder. It's by far not the best circuit board holder that I've got, but it'll do the job. As usual with these inexpensive kits, you don't really need an assembly manual. All the part numbers are labeled on the board, so that's not all that difficult. There's the two 1 microhenry inductors, and there is a 0.1 microhenry inductor. And as we can see, we got 2 of one and 1 of the other, so that's pretty straightforward. We got our 2 larger capacitors, our push buttons. The smaller ceramic capacitors, looks like there's a couple of different types of them. Alrighty, the battery and the crystal. So I think we will get started with the inductors just because they are the least likely to get damaged by ham-fisted soldering. So might as well put them on first. Now this is the single one, which is going to be the 0.1 microhenry. But just in case we can't trust them, we'll test it for ourselves. 0.12. That is what that guy is. Guess I shouldn't have been surprised. Might as well put the other ones in as well. Should I put some of the ceramic caps in first? I'm not sure. Huh, there is a resistor came with the kit. That doesn't show on the schematic that I found. But it goes down here. It says it's a 30K. And I think that is enough components for the initial solder batch, just to get me started here. Normally you don't want to preload too many components at once because they just start getting in your way. It becomes an ugly little forest of components on the board. This is a comfortable number. One thing I've got to be a little bit careful of is lead placement in relation to the chip, because that chip could get hard to solder down. But I kind of want to put it down as close to the end as possible, just so it doesn't get damaged. So I will carry on with the low likelihood to cause damage components, such as the mechanical stuff like this jack here, and a bunch of switches. The nice thing about these little switches is you don't have to bend the leads because their leads are already bent, so they will just snap into the board and hold their place when you flip it over. This guy's going together really, really quickly. Let's get these little ceramic caps in next before they fall off my bench and I lose them forever. So we have 3 little ceramic caps, a 103, which is 10 nanofarads, a 223, which is 22 nanofarads, and a 24, which doesn't show up on my chart, so I'm not quite sure exactly what it is. But it doesn't really matter because their part number is what's labeled on the board, so that makes it easy. You don't have to know for absolute certain what it is. Just read the part number and go. And while we're doing capacitors, we might as well do the 200 microfarad DC block caps, which are called C4 and C5. Negative goes to the right hand side, stripe is the negative side. Well, this is low voltage enough that I don't suppose it's going to cause any catastrophic failure. If they're in backwards, it's just not going to work as effectively. Let's make sure there's enough lead on those to fold them over so that they sit flat like they're supposed to. Right. There's only 2 components plus the power pack left. So let's stop procrastinating and tackle the little integrated circuit here. There's no direct pin 1 marking, but there is the notch at the end, which means that this over here is pin 1. And on the chip we have this dot indicating that that is pin 1. I will first just tin one pad on one corner. I'm picking that one just because it's the easiest one for me to get to. And then try not to be too shaky. Yeah, that's not going to happen. Get in there and tack that corner down, and then take a close look and realign the chip. Nudge it into position so that all the pads actually line up where they're supposed to be, like that. And then put a drop of solder on another pad. Let's pick this corner down here. Okay, that should have it anchored in place so it won't move. I'm still practicing, still learning with surface mount, but I'm getting better. I think that's going to work. The next half of this trick is just not creating any solder bridges. But you work slow and steady and you can get her done. If an old bugger like me with shaky hands can manage it, I'm sure most of you guys can eventually too. Just put in the practice, like anything. That's a bit blobtacular. I don't think it's shorting anything. Before I forget, I'm going to just reflow the first one. Good. And then I'm going to get my head in here a lot closer, which means you guys won't be able to see what I'm doing, but I'm going to solder up the rest of it as best I can, and I'll come back and let you help me inspect it afterwards. It's not beautiful, but it's electrically sound and nothing is shorted. And that's good enough for me. So the last component to put on the board is the crystal. It goes in those two pins beside the chip right there. Right here, Y1. And again, it bends over flat against the board like that. We'll just solder him in place. Get him tacked down in place here. So the only thing left is the power. And judging by the tie wraps in the kit, it would seem to indicate that this is supposed to get strapped onto there. These pair of holes and these pair of holes. Yeah, that seems reasonable. And where does the power leads go in? They go on over here. Oh, that's an awful lot of wire. I think I'm going to shorten it up a little bit. Maybe about that much. Hope it's not too short. So positive there and negative there. Yeah. Except for they got to come from this side. So poke them through those little stringy leafy holes first, and then back around and out the other side. This shouldn't be the hardest part of the buddy kit. Get in there. Okay. There. That was surprisingly frittery to get those little buggers in there, but perseverance, swearing, and a bit of beer always comes through for me. Pull the little strainer leaves up nice and tight, and that can get strapped on. And as always, if you don't use flush cutters to trim your ties, you're a monster. Your coworkers will hate you. Future you will hate you. Just use the proper tool. I know often I use whatever tool's handy, but this is one case where the proper tool really, really matters, because you don't want to be leaving sharp ends that'll slice you up later. And trust me, they will. There we go. Done. So now we need a couple of AA cells, and we need something to plug this into. One moment, please. All right. We'll get some quality dollar store Panasonic cells in here. It's a little tight, but we can work around that. That's cool. Connect the audio output to a little powered speaker that I got off to the side here. Oh, hey, we got music. Distorted music. Let's see what happens when we tune the channels a little bit more here. So obviously I'm not going to stay on any channel very long, because I will get nailed with copyright. Oh, that's not going to cause me copyright strike probably. It's not this best high fidelity. Nice. But I think it's listenable.
Bus shelters, and with all the assaults in the city.
Yeah. I think that works pretty darn well, actually. I mean, it's obviously not high fidelity, but for a first try, for a simple, cheap little kit, I think it was definitely less than $5. Probably in the $3-4 range, if I remember correctly. There'll be a link down below to the mailbag where this thing came in. And as I mentioned before, it was packaged with a transmitter circuit. This, I think, is the better of the two circuits from an audio quality point of view, and also it's much more beginner friendly, except for the surface mount chip on the other side. Everything else is really, really easy, and as a first surface mount kit, that's not a bad choice for somebody who's just getting into this stuff. I like it. Definitely recommended for any newcomers who are wanting to get some practice soldering, building kits, and just tinkering with electronics. Well, thanks for watching, everybody. I appreciate it as always. Questions and comments down below. There will be a few links down there as well. I'll talk to you later.